Hello everyone, this is Meera Jaydevan joining you again on behalf of OWASP Kerala, and as a Women in AppSec initiative, we are welcoming you all to another webinar session. The OWASP Foundation is a global organization that works to improve the security of software through its community-led open source software projects, hundreds of chapters worldwide, tens of thousands of members, and also by hosting many local and global conferences. Its Kerala chapter was founded in the mid of 2006 by a group of security professionals and enthusiasts. And this chapter conducts events like seminars on cloud security, social engineering, cyber laws, mobile application vulnerabilities, online women's safety, etc., to create awareness on the security and safety among the common public. It also provides opportunities for the upcoming software communities to present their contribution to secure the application development. Today, we will be discussing the topic Eliminate SQL Injection on the Planet, Easy and Precise Detection. And this session will be taken by Ms. Fani Madhavi. Ms. Fani Madhavi is an associate director in a leading MNC and has 2+ decades of experience in developing computer and web applications. She is extremely passionate about building robust enterprise applications with a specific focus on the software security and has received award of excellence for her work. She has a thorough grasp of these OWASP recommendations for security, understanding of the business processes, and suggested innovative solutions for the applications at the stage of the web application development lifecycle. And she has also managed teams of size of 250 plus and has extensive exposure to guiding and training teams. So coming to the topic, SQL injection holds a very special place in the OWASP top 10. So the impact of the SQL injection is that the source of truth of the business data can get corrupted, deleted, stolen, all of which are highly detrimental to the successful running of the business. We all need to get together for a common goal and eliminate this SQL injection from this planet. So, what does it take to do this? Let's wait and hear. Now, before I hand over, we would love to hear from you. So, please drop your queries in the comment section on the Facebook and YouTube channels, and will be acknowledged at the end of this session. Welcome, Ms. Madhavi, to this OWASP Kerala chapter meetup and as an initiative for women in AppSec. And you may please take over the session.
Thank you. Hello, everyone. Welcome to this webinar on eliminating SQL injection on the planet. It's a very tall claim, but I believe that with rigorous effort from each one of us, it is definitely achievable. I'm Fani Madhavi, and thank you, OWASP Kerala, for giving me this glorious opportunity to present this tall claim. Just was thinking about a novel way to introduce myself. In this slide, please see the point I'm trying to make. If you see, we have an application hosted in OWASP Kerala. This is an assumption. And we have to get to the details of the speaker, in which case it is today, myself. I would normally do a GET request as shown in the slide. The one highlighted in red is the point of our discussion today. And given that it is an OWASP site, I strongly believe that there is no issue, and there would be no issue going forward as well. Now, for the curious ones, what do you think is the issue in the request? And what could it possibly do? You may please feel free to type it out in the comments. Also, along with that, it would be really great if you could list out your expectations from this webinar and if you are looking for something specific. And please do add it in the comment section as well. I think Meera did cover a lot about myself, so I'm not going into the detail of myself, but I just would like to mention 2 points. One, the passion I have for building robust enterprise applications with focus on security. I believe in secure SDLC, where security is embedded in each stage of SDLC. I received the CEO Award for Excellence for my work, and I recently authored a book on SQL injection as well. Moving on. I'm also a great fan of reusability. You can also read it as being lazy. In one of the applications, we cut the code size to 10%, not by 10%, to 10%. Moving to the next slide. So here are my contact details. The best way to reach out to me is via email. If you have any topics which you need more clarity, you can please feel free to shoot an email. I'm assuming that the cross-section of people whom we have here today fall in one of these categories of dev, QA, DevOps, DBA, managers, security consultants. If it is a different category that you fall into, please do mention in the comments. Today, I'm going to take you through the journey of detecting SQL injection using white box techniques and make you understand the need to prioritize SQL injection. And once prioritized, how can you easily figure out the injection issues in your system? DBAs have the ability to try this out globally on all applications and can make sure that the content is safe. QA and IT managers can also put in their bit by regularly monitoring the SQLs coming out of the systems they own. In this way, everyone can play a part in the secure SDLC. I believe secure SDLC gives an opportunity for every stakeholder to have a sense of ownership in building a secure application. Now, of all the kinds of vulnerabilities, why only SQL injection has to be prioritized? In May 2020, a New Yorker was charged for hacking into e-commerce websites with the motive to steal credit card information. It was reported that the hacker, along with his gang, used SQL injection techniques for hacking into the vulnerable e-commerce websites. And not only that, look at the caption of the SQL injection exploitation tool, SQL map. It says, automatic SQL injection and database takeover tool, highlighting the database takeover tool. If your application is not careful, not only your application's data is compromised, but the data of other systems residing on the same database server is also compromised. Typically, database server resources are shared among multiple applications, and not every application gets its own exclusive database. A small question to the audience. Now that we have seen how SQL injection can disrupt the business, what do you think is the percentage of SQL injection in internet-facing systems? You can type your guesses in the comments. I'm looking for a number between 1 to 100. What do you think is the percentage of SQL injection of all the issues? I think, any guesses? Okay, 20% I see. Any other guesses? 60, okay, good. So I think both are kind of closer to what the actual number is. If I show this, yes. As per this report, this is the Edgescan report. And as per this report, it stands at a whopping 42%. That means it is very relevant even today. My dream is to eliminate this and hence this presentation. In my experience, every person thinks that their code doesn't have any vulnerabilities. At least it was that in my case. I did think that. But how do we prove that we don't have any? We cannot wait for someone to come and show us that there are issues. And some code analysis tools may not be able to even detect the issues. In this presentation today, I will demonstrate easy and precise techniques for SQL detection, which can be checked by anybody with minimal knowledge on SQL. I'm sure all of you might be familiar with this, but still, I'll just take a moment to go over this. SQL injection usually occurs when you ask user for input, like their username or user ID, and instead of a name or ID, the user gives you a SQL statement that you will unknowingly run on your database. Hacker injects malicious data in the user input, application doesn't know, and gives it to the database for execution. Typically, when we go to training programs, we are taught what is SQL injection, how can it be exploited, and how can it be remedied. If you see in the SQL, in the insecure query taught in the training, you can see the user first name variable. This user first name variable is concatenated in the query itself. And that's what makes this vulnerable. In case you do not understand this code, don't worry. It is just trying to prepare a SQL query in Java to be executed and trying to retrieve the results. The point to note is that the user first name is provided by user. This is the crux of user taking control of the application with his input. And if you do look at the secure one, the change was to introduce a named parameter. And SQL injection examples often taught in training programs are pretty basic. And once you are done with the training program, you feel like you're ready to conquer the world. But when you take a look at your real queries, you're confused. You're not really sure whether this is exploitable or not, whether this has SQL injection or not. Did this happen to you anytime? Please do mention in the comments whether you had any kind of confusion on in a real analysis, whether the queries had SQL injection or not. Would appreciate if you can mention it in the comments. I remember I met a person one day who was learning car driving. He said he can drive the car in a big ground where there are no people moving. It absolutely serves no purpose. So unless you completely understand how to tackle SQL injections for complex queries, it may not help in real life applications. So how can we be better equipped to handle the reality? Now, a quick question to the audience based on the information I just provided. You can see two queries here, query A and query B. And I have highlighted the difference as well in turquoise, where in the first query A, username is passed by the client to the server. In the second case, it is not passed by the client, it is there in the program itself. Which queries in this one, query A or query B, has SQL injection? Anybody, any guesses? So the question is, we spoke about insecure query and secure query. In the query A, the username is passed by the client to the server. In the query B, username is not passed by the client, but it is in the program itself. Okay, one response is query B, one response is query B. Okay, so let me reveal the secret. Here, always please note that any user input is untrusted. If you are getting something from the user, then definitely it cannot be trusted. Unless you have a very rogue developer, you might not have the issue in query B. The query A is one which is exposed And if the system is internet facing or even intranet application, you could have SQL injection issues. So always look for if the variables are actually coming out from the client or being introduced in the system itself. You would definitely have SQL injection when the username or any user input is being passed from the client by the client to the server. I hope it is clear. Then moving on, for us to understand how to solve the SQL injection permanently, we need a better understanding of the journey of the query. What do I mean by journey of the query? And for showing the journey of the query, you would need to know the typical architecture of an enterprise system and how an ORM works. I'm assuming that everybody viewing this webinar is aware. In case you do not, you may please shoot out a question. I'm not going to spend too much time explaining this. This is a typical enterprise architecture, but at a high level, this is your web server with redundancy. This is your app server with redundancy, your database, and you have multiple availability zones. And your application resides here, obviously with redundancy. Your application resides on the application server. And going to the next one, which is a blow-up version showing the ORM. Here you see this is the place where application would be hosted. And in your application design, you would have an ORM layer. Regarding ORM is nothing but object relational mapping layer. If you already know about it, great. If not, it is nothing but the tool which translates the data in the object model to the data in the relational model. I repeat, data in the object model gets translated to the data in the relational model in the database. So now coming back. So now what do I mean by observing the journey of query? The query is initially written in the application. Here it's Java code. The database only understands SQL. It doesn't understand the object model. It understands only the ER model. So it's the ORM's job to prepare the SQL and then pass it on to the database. The transformation of the query in each step is depicted here. Now let's observe the journey of the insecure query. I'll give a little more detail here on this color coding. If you see the color coding, the show SQL is which will print this statement here. They use SQL comments true. This is what prints this dynamic native SQL query. And the hibernate type trace is what will print these statements here. So you can just match it with the color coding here. And another important point to note is that all these values which I am showing here are not to be set for production. This is purely an exercise to understand how the flow, how the query gets transformed across different layers. But in production, you would have all of them as false because it has a big impact on performance. Now, so here I'm seeing that user first name is passed by the client to the server and it is equal to John. If you see, I'm just concatenating the string here. So the query that had to be constructed was select first name, last name from table employees where first name equal to. And that's what is replaced by John because that's what we received from the client. And that along with the SQL comments true is passed to the database. Actually, here I do not really see the benefit of SQL comments going to the database. This is all traveling over the wire. So better, unless we really want to show something at the database level and want to see, analyze it later on, this can be always false. Now focusing on these two parts. If you see the string John is concatenated in this statement, and this is what is going to the database. Now, I will move to the secure query part. If you look at the output from these secure query, so in the secure query, what are we doing? We are still getting the user first name from the client, and it is coming from the client and then gets passed on to the server. And here I'm using a named parameter, and that's how I'm assigning the user first name as John here. If you see my previous one, here I'm just concatenating. Here I'm setting a parameter here. So now you look at how the ORM treats this specific query's output. If you see, the rest of the statements here are the same. If you see, you have this one, sorry. You have the results that are the same. But there are few minor changes which have a big impact. What is that? You can see that this is a binding parameter. The string John is being passed to the database as a binding parameter. And instead of you having the first name equal to John here, you are having a question mark. And if you see how it is in the database, you can see that in the database also, it will not be represented as after a.first name, it will not be John directly. It will actually be passed separately, and then that data type is mentioned here. Data type and then the size, etc. This is a real statement from the database. In fact, it is like I have taken it from Microsoft SQL Server. But typically, any database, the actual representation might vary, but any database would do the same. So I'll now comes the critical part. Let us, we have seen both secure and insecure queries. Now is the time to really compare both of them. This is the slide in which I want all your attention. Request all your eyes and ears be here. You can see the, you can see the SQL insecure queries output. This is the secure queries output. And this is how it goes to the database. A small question to the audience is that, what is the difference between the two? I know, like, I have highlighted in red. I think that's the big clue. But still, I would like you to understand what is the difference between these two. And with this information, till now, what we did top down. We had the query from the application, got it to the ORM, and then the database. Now forget the application code. You just have this ORM output. With this information, how can you detect the SQL injection? Any guesses? Any guesses on what, with this information here, how can I detect SQL injection? So maybe then revealing the actual secret. If you see, as I have mentioned, you have the username, the first name equal to John here, and first name equal to question mark. You can see that in the secure query, it is question mark. But in the actual query, you have a string. So this is the crux on how you can identify SQL injection with 100% accuracy every time. After any relational operator, check if you have any question mark spewed out by the ORM. In case it is present, it is good. The application is safe. If not, it's time to rectify. Given the very critical importance of the slide, I'll repeat. In this slide, we are talking about detecting SQL injection with accuracy, with 100% accuracy. So I see that in the insecure query, I have the string John appended in the SQL, concatenated in the SQL statement itself. But here in the secure one, I do not have it. I only have a question mark, and there is a binding parameter attached to it. So the crux of how you can identify SQL injection with 100% accuracy is that check if your ORM is spewing any question marks after a relational operator. In the current example, I have taken Hibernate, typical Java stack, enterprise Java stack, but the exact symbol may vary depending on the ORM, but the concept doesn't change. This holds true for any kind of ORM, and the statements that you see here holds good for any kind of database. So as long as you can see that you have a question mark spewed out by your ORM, you are absolutely safe. In case you can't get an ORM output, normally you will be able to retrieve all the queries that are going to your database. If you can't get it, you can just go to the database itself directly and then check. In the database, if you find anything with equal to and then you just see the real value, then you have a problem. Okay, I hope everything is it is clear for everybody. Then moving on. Now we have learned, okay, we have learned how to identify SQL injection, what is secure query, insecure query, and all the statements which I have given so far in the examples, they were only SQL select statements. Now the question to the audience is, does SQL injection apply only to select, or does it apply for insert, update, and delete also? I'll give a moment. Does SQL injection apply to only selects, or does it apply to other SQL commands? Any guesses? Yes, no. Does it apply? Yes, or does it not apply? Okay, so I'll probably reveal it myself. Yes, I think the answer is right. Thank you, Niyaz Hashim. The answer is right. The SQL injection does not care what kind of SQL statement it is. If there is a SQL injection, the issue can be there in selects, in inserts, updates, any kind of commands. So it is not that you just take care of your selects only. You have to take care of every SQL statement in your system. So moving on to the next one. So here we will talk about the different types of SQL injection. SQL injection is broadly classified into in-band, inferential, out of band, and second order. You can see the different categories of SQL injection here. I'll give you a moment to digest this information, because this information is very good to know when you are dealing with SQL injection. Assuming you have digested, I'll go into the detail of each one of them. Inband SQL Injection. Inband SQL Injection is the most common and easy to exploit SQL injection attack. It occurs when the attacker is able to use the same communication channel to both launch the attack and gather the results. The two most common types of inband SQL injection are error-based SQL injection and union-based SQL injection. Now let's talk about the error-based SQL injection. In the error-based SQL injection, error messages are thrown by the database server to obtain information about the structure of the database. In some cases, error-based SQL injection alone is enough for the attacker to enumerate the entire database. So the crux is the database errors are finally being shown to the user. That's the crux. That's how error-based SQL injection works. Coming to the next type of inband SQL injection, which is union-based. The union in this union-based SQL injection, the union SQL operator is used to combine the results of two or more select statements into a single result, which is then returned as part of HTTP response. In the case of Hibernate, HQL doesn't support union, but obviously if you have native queries, and definitely SQL supports union. And you can see the two key requirements for this union query to work. The individual queries must return the same number of columns. The data types in each column must be compatible between individual queries. Moving on. Inferential SQL Injection. In Inferential SQL Injection, no data is actually transferred via the web application. An attacker cannot see the result of the attack in the same communication channel. But then how does he know? He evaluates the output. Let's talk about the inferential Boolean based and inferential or blind time based. In the Boolean based, the attacker sends the SQL query to the database. And what does the SQL query do? It forces the application to return a different result depending upon whether the query is true or false. If you see here in the payload, 1 equal to 1, 100% time, it is always true. So the application responds with some type of result here. And he can put 0 equal to 1, that is 100% false every time. So if the application's output changes based on this payload, then that means there is a SQL injection buried in there. Here, even though there is no data returned from the database, based on the output, there is an inference made by the hacker. Hacking is a lot about making inferences. So in this case, it is inferring how sending 0 equal to 1, which is false always, 1 equal to 1, which is true always, and trying to infer. Moving to the next one, the time-based SQL injection. Time-based SQL injection is an inferential technique which relies on, again, sending the SQL query to the database. What does it do? Here, it forces the database to wait for a specified amount of time before responding. I repeat, it forces the database to wait for a specified amount of time before it responds. If you look at any of these SQL injection proof of concepts, this is typically the method used. We are trying to delay the response of the database by introducing a sleep. And if you see in my in the first slide of my introduction, that's what I had shown. Maybe I'll just go to the beginning. If you see here, this is what I had done. Okay, this is the best example from a time-based SQL injection perspective. So in this, the response time will indicate whether the result of the query is true or false. And this has the potential to cause a denial of service. We can just say sleep for 1 day or 1 hour. So that database will not be responsive. The other types of SQL injection are out of band and second order. Out of band SQL injection uses a different communication channel altogether for the request and response. In the case of in-band and inferential, even though whether the database is sending a response to the hacker or not, it is the same communication channel. You send the HTTP request, you get the response, and based on that response, you try to decipher whether there is a potential SQL injection or not. But in the case of out of band, it's a completely different communication channel. It's potentially much, much more dangerous and very hard to detect. The second order SQL injection, the untrusted data that is being sent as an input by the user, it is stored in the application and it is then later used in SQL queries in an insecure manner. Then it can be either in band or out of band. If you see, of all the things, the worst possible thing to detect is a second order out of band. You can't even know whether something else has happened unless there are some other ways of detecting this issue. Any questions so far? Okay, I believe I'll just, if there are any questions, please do mention in the comment section and we'll have a Q&A session as well. Now, a quick question to the audience. We saw SQL injection using users' keyboard input, but nowadays you're seeing a lot of applications being developed which are voice-based. So can you have SQL injection using users' voice? I'll give a moment for everybody to take a guess. Yes, do you think using user's voice you can have SQL injection? Or no, that's not possible? Any guesses? I know this one is kind of a little tricky, and probably I would categorize it as a next-gen attack. Most of the material on SQL injection doesn't talk about this user's voice being taken as an input. Okay, one person, Alan, says no. Okay, don't know. Okay, don't know. Okay. So yes, I'll give the answer out. You can have SQL injection with user's voice as well. It does not matter how the input is coming. The user's voice can be translated. We have seen SQL injections based on true false, where the attacker can actually give a SQL statement which always can be like a 1 equal to 1 Boolean based, always true, or 0 equal to 1, which is always false. Like that, you can give the input to the voice recognition, apps which are voice enabled, and you can craft the input using user's voice in such a way that it can execute SQL injection. Obviously, the basic requirement is something has to be stored at the database level. That's the prerequisite, obviously. And it does not mean in any way that the existing things in the market, like the Alexa, they may not be the ones which are susceptible, but the applications using those APIs and how they are using it in their applications, that is what will make it vulnerable. Okay. Based on taking a cue from this, there is another possibility. So we have seen all the user input. Typically, at the forms, you have user giving you data, username, password. You take some forms. You have several ways in which you get users' data into the system. Then the second possibility is that the things which are not directly given by the user, but in some way they get to the application. For example, you have HTTP headers, you have cookies. The question here is SQL injection possible using cookies, using HTTP headers, like referrer header? Is it possible? The answer is yes, it is possible. If the cookies are, just look at any data. The database does not know whether the data is coming from your form, from your cookie, from in which way the untrusted user input is coming into the system. As long as you have untrusted input coming into the system, and if it is getting stored in the database, or if it is some way connected to the database, you have the possibility of a SQL injection there. So many of the time, the checks on the application are only done on the forms, on typical data, like that is being spewed out by the ORMs, etc. But if you are not checking if anything else that's getting stored in the database apart from your application's data, like cookies, anything else being stored, you must have a checkpoint to make sure that they are also validated for SQL injection. Moving on. Here, we are talking about data classification. First of all, why do we need to do data classification, and how does it impact security? Data classification is the first and foremost step that needs to be done before you even design your database. Before you come up with the ER model for your database, you must have a data classification. Normally, it is all done when the application is probably in production, and then you then try to identify, okay, what is my data? That's probably the, I would say, it'll require a lot of changes if you take that route. The best way to do is to have the data classification as the first step before you design the database. Why? Because this data classification will make you understand the protection mechanisms that the data needs, and it will help make design decisions for the software and infrastructure. You also would need to understand the legal compliance. If you know about the data classification, then it will be much easier to understand what legal compliance procedures you would need to follow. So that's why data classification is required. And how does it impact security? Yes. So I would make the design decisions in such a way that if there are much higher, severe data classifications, like, it is very confidential, and if data is leaked, if that has a major impact to the customers, then we would need to figure out how the data is getting stored, how the data is getting transmitted, what are the encryption mechanisms that are present when the data for data at rest, what kind of encryption mechanisms that have to be put in place for the data in motion. All these design decisions depend on this basic data classification. Controls at the database and the application level. Step one is obviously to figure out whether you have issues or not. But even before you come to that step, at the design stage itself, we can take certain steps. From an application standpoint, authenticate and authorize access to the data via the APIs. If in case you are using a typical enterprise systems like with enterprise stack like Spring Boot, etc., Spring provides certain annotations which can help you pre-authorize or post-authorize. And I'm sure every other tech stack out there will have an equivalent of that pre-authorize or post-authorize. Now, where should we put it? It should be at none other than the method level. Every method, if you have a controller, every method in the controller must have a pre-authorize, which will tell which role in the application can access that method. That way, you are securing your data as well. Then obviously you secure the queries to the data. That's how you secure your queries. I'm assuming authentication is something which already many people, every application has an authentication, but the recent standards indicate to go for a token-based authentication than just a basic authentication. Then the third step is cutting down the verbose error messages. Normally, when typical application has a predefined set of error messages that it can send, and something which it probably didn't know that would happen, it may actually spew out a lot of information. The application design has to be in such a way that the verbose error messages must be confined only to the logs. They must never reach the user. You can have a kind of a mapping for the error, what is shown to the user. You can have some identifiers and then map it to your logs. But the actual error message, your database had some error, the query did not execute properly, query syntax was incorrect, nothing should go to the user. Then coming to the database level, as we have seen, there are, if you look at the time-based SQL injection, that means that there is a possibility of a DOS as well that can happen. And there are also ways and means. Normally, applications can have a throttling defined to see how many requests can come in, and application should have a defense mechanism for the DOS. On top of the applications, when I say application, the infrastructure, the load balancer, there will be configurations around it, which has the ability to throttle connections. But that is not enough. The throttling of connections not only should be at the load balancer level, but it also has to be at the database level. So that not too many, you have an understanding of how many requests are coming to the database on a typical day. And we should define the threshold so that the connections are throttled at the database level as well. And the second point is normally ignored all the time, but it's a best practice to make sure it happens periodically, at least once a quarter. The passwords, the application connects your database through an account and it has a specific password. These passwords normally are not set to expire. Other user related accounts, they will probably expire. Typically, that's how the policies are set. But the application related passwords, if they expire, one day the application stops working. We should not have that. But at the same time, there should be a coordinated effort to set the passwords manually, reset the passwords manually periodically. And the third point that probably is not a typical situation nowadays, but still the DB server, you should never have the data and the application in the same server. And last but not the least, if by chance you have to store user's password along with the credentials, then the best place to refer to is the OWASP cheat sheet series for password storage, how to do it with all the bells and whistles. This is probably from an authentication perspective, the most rigorous exercise that need to be undertaken in case you have to store your password. Then how do we make sure that it happens continuously every time? You just, okay, analyze one day all your SQL queries and you're done. That's not the case. It must be a practice to make it happen and make it as a part of the process itself. For each application, I mean, an application can be in a development mode, or it can be in a maintenance mode, or enhancement mode. In whichever mode the application is, there has to be regular intervals that have to be defined where the queries from the application are reviewed. As part of the code review, the ORM spewed SQL queries also must be reviewed, and they have to be analyzed, check for question marks, check for, like, if the string itself is coming in the SQL statement, and then store this analysis in such a way that it can be used for reference in the subsequent analysis. And I'll mention few tools here. I mean, obviously, all the tools and all the diagrams which I have mentioned here, disclaimer, the corresponding authors, owners own it, and it's not my proprietary one. Even the one tool which I'm going to specify, like P65, this tool I have seen that we have a Hibernate output which will give me the output of the binding parameter and the the output, the results as well. But if I want to just get the SQL statement which I can execute in the database directly, this is a proxy which can help you in getting the SQL, how you can actually execute it in the database with the actual data. These kind of tools can actually help you quicken the process, but still the effort is required from your side. I would like to take a moment to mention the book. This is a book on SQL injection. Just I thought of mentioning here. And the next steps that I would request you to mention are: the first one, mention the topic that you would like to know more about and any feedback that you would like to share. I think we will have the feedback form link that will be given by the organizers in a moment. So please feel free, or rather request you humbly to provide the feedback so that we can definitely improve upon. Hi, Meera. I think we can go for the questions.
Thank you. Now we are open to the Q&A session, and our speaker will be responding to the queries from the comment. So please do comment your queries, and we'll be responding it back to you. Any questions? Yeah, so we have a question from Angel Riz here. What's the future scope for cybersecurity?
I think this is a very broad scoped question, but thank you for asking, and I'll try my bit uh, to figure out the response. When we talk about cyber security, nowadays, mostly the attacks that we are seeing are either by, like, the, I mean, obviously the people who are trying to figure out the issues, pen testers, or there are people who really want to harm the systems. And the future of these cyber security, which I see, is that less and less would be manual kind of attacks. There are, for if you look at any kind of um, hacking sites, there are every day a lot and lot of automation tools are coming in, which can really disrupt the manual way of identifying issues. So in future, if people who are in the field of hacking, for them, it will be good to figure out certain niche areas, like, let's say, remote code execution or race kind of vulnerabilities, where sometimes it is not possible by a system to automate it, but it definitely needs a human brain to look at those kind of issues. So focusing on those kind of issues would what will help in the future for the teams who are interested in this hacking. Then
Next question is, ma'am, any POC regarding the SQL injection over voice?
yes, I have seen actually write-ups on the voice-based SQL injection, uh, the how the user crafts the input from I have read an article around it which talks about using this Boolean kind of SQL injection, where adding a true at the end, and then trying to figure out if the system has any SQL injection issue. I believe it is still in the nascent stage because we have a widespread use of applications, mobile applications, web applications, but voice based, I don't think I mean, it is still emerging, and there are probably certain applications already out there, but not to that extent. So I don't have a real example, but the fact is it is possible.
Next is from Devesh Mohan. Does parameterized queries help to completely eliminate SQL injection, and or does they have any loopholes as well?
Parameterized, if you look at my Bible, is OWASP cheat sheet series, and it states that parameter for us to make sure that SQL injection does not happen, the only solution is parameterizing it, and make sure that in the parameter itself you are not concatenating it, you are adding it separately into the query. So my Bible is OWASP cheat sheet series, and I go with it. It should not have any issues.
From Natalie, one critic of coloring coded samples. For clarity, use red for warning stop and green for acceptable go.
Sure. Thank you. Thanks a lot, Natalie. Thank you for joining, and point taken. Thank you.
From Kabul, please repeat the tools you mentioned for testing SQL injection.
The standard tool that we use for SQL injection is SQL map. I'm just typing it here. SQL map. This is SQL map. I can state that there is something like HQL map, which is specifically for Hibernate query language. But SQL map is the most common tool that is used for figuring out SQL injection. I mean, when you do not have a white box way of identifying, that's when you resort to these tools. When you don't have access to the source code, when you can't see the SQL queries coming out from the application, you can use SQL map. But it's very laborious process. If you have hundreds of APIs in your system, it might take a lot of time using these tools. But if you are on the other side, on the pen testing side, obviously you don't have a choice but to go with this. Then the other tool as such, it's not for pen testing per se, but it will give the exact SQL query what can be executed in the database. That was P6Py. P6Py. It's a proxy, database proxy. I hope that clarifies.
I think so. I have a question, like how SQL injection is different in NoSQL databases.
Okay, so if you look at the main difference between a SQL and a NoSQL, you have a relational model in a SQL database, but it does not mean that NoSQL databases, because they don't have a SQL, they are not vulnerable. There are injection issues possible in NoSQL as well. And that is a completely different topic altogether, because the way the data gets stored in a reference in a relational model versus in a NoSQL, it's like typically like an object model. That's how the data gets stored there. So the injection techniques, if you look at OWASP top 10, they say injection, and SQL injection is one big part of it, but there are other injections as well, and NoSQL also stands there. And there are specific injection techniques in NoSQL and remediations. And of what all I have seen, any kind of injection, take it excesses, any kind of vulnerability, you can mitigate by appropriately validating the user input. Always think that user input cannot be trusted. As long as you follow that golden rule, I think that's one of the, almost every place in OWASP cheat sheet series and many other references, they state that user input is always untrusted. As long as we take care of that, without probably our knowledge, we would have mitigated it. But if we have not, there are NoSQL injections as well.
Thank you.
Okay. Any other questions?
Any more questions? Anyone? Okay, I think there are no more questions. Thank you. So that was a very informative and very much interactive session, and we could grasp really useful information this evening. And we are very, very grateful for your expertise and for your valuable suggestions.
Thank you for having me here. Humble thanks once again.
On behalf of OWASP Kerala and Women in AppSec Initiative, I extend my sincere thanks to you for being with us today and for being very interactive with us. Also, we are sharing a Google form here, and I request you all to provide your feedbacks there. And also, there is a small announcement. OWASP Kerala is inviting quality papers for upcoming webinars. And so, if any of you is interested in to be our speakers, please do share your paper and topic with details with us. For more details on that, please visit the OWASP Kerala website and their social media handlers. And the next meetup for us is scheduled in Jan 2021. So for more details, on the topic and the dates, please keep on checking the announcements in the social media channels. Thanks to all who tuned in. And please don't forget to give your feedbacks in the feedback forms we are sharing. Thank you all. See you all again. Stay safe. Thank you.